Hello, welcome to the Graphs and Tables video for research methods. Okay, so for this flip video, please listen carefully, write a few Cornell notes while you're watching. If I ask any questions, if you can just note those at the bottom, complete the section of your mind map, and if you have done all that, please go and read some of the textbooks on this area. Okay, so this is kind of a big section. What I've tried to do as best as I can is draw some of these graphs and tables up for you. I'm mostly focused on not only how they're drawn, but also how they'll be marked in an exam. Okay, so what are they? So a table is about presenting data, so they're easier to understand. So raw data is the data that you would directly collect from participants, so their initial scores. This then should be summarized in smaller tables that would show the descriptive statistics. So descriptive means to describe, obviously. So mean, median, mode describes the measure of central tendency. Let's have a little look at these. So, that would be an example of a raw data table. So participants 1, 2, and 3, what they got in condition A, what they got in condition B. That's fairly simple. Or we could use a frequency table to record perhaps behavioral categories. So 1, 2, and 3 maybe represent 3 different behavioral categories, and we just mark them off. Both of those are raw data tables. That's a summary of descriptive statistics. So we can see here that we've got a mean of 32 for the males and a mean of 24 for the females, a range of 4 for the males, range of 8 for the females, and a standard deviation of 1.2 for the males, standard deviation of 2 for the females. So what we can say here is the mean score for the males was much higher than the score for the females. However, the scores were far more spread out for the females than they were for the males. So the males' results were closer together. So we might have a piece of research, and it asks us to read through the study, look at the summary of descriptive statistics, and then say what the summary of descriptive statistics tells us about the research. So in this case, we'd say the males had a higher score in whatever it meant, so perhaps aggression. However, the females had a wider range of levels of aggression shown. Okay, and here we have a contingency table. So these tend to be used to collect data and then see the totals of each variable. This is going to be used for chi-squared, for the statistical test for chi-squared. And you can see here, so there were 3 males in condition 1, 3 males in condition 2, so we had 13 males in total. And then we can see the total of females as well, and we can see the total of participants in B and total of participants in A. Okay, I'm going to talk about some graphs now, just what they look like, how you might draw them out, and more importantly what the marks are available, because a number of times I've marked graphs and you seem to do the hard work. You spend 5 minutes drawing out this beautiful graph, quite often only gaining 1 or 2 marks because the really simple stuff just isn't there. So we get a mark. I mean, sometimes it varies, but generally get a mark for a title. Start with a graph to show, or if you can be a little more fancy, what type of graph it is to show. And then effectively state the hypothesis. If it's already given you a hypothesis, write in the hypothesis. But you want to talk about the IV and DV, or the 2 variables that you're measuring against each other, what's on the x-axis and what's on the y-axis. Okay, a suitable axis. So this means you haven't drawn a massive scale and maybe your bars are just sitting right at the bottom. It means that you're using the page effectively. Correctly label axes. I mean, this is probably the one that this and the lack of a graph that I tend to not see done. Is you just need to write what's on the axis. It's not good enough just to put numbers. What do those numbers represent? And then correctly plotted data. This is probably the one that people stress out about the most when it's only 1 mark. I would much rather you get the rest of it right. You actually draw a decent axis, a decent title, and collect the real axes, and not plot your data as effectively, because people just focus on this correctly plotted data at the and ignore the other 3, and potentially lose a lot of marks. Obviously, go for all 4, but it's not all about just plotting the data. It is about the graph as a whole. Okay, so let's have a little look at some of these. So this is a bar chart. So this is for non-continuous data, so data in categories. Look at levels of measurement if you're unsure about what this means. Now, the big mistake I always find with this, with a number of students every time they go through it, is they will touch, the bars will touch. If the bars touch anything, it is not a bar chart, it's a histogram, and that's for continuous data. So you've just drawn the wrong, graph. So make sure there's a space between your axis and the first bar, and then another space before the next bar. You know, they're going to stand independently. As you can see here, axes, there's an axis label, a title, another axis label, but also a label underneath each bar to say what the bars are. That's what they're going to be looking for in a bar chart. I think quite often people rush these, and I'm always surprised how low these score when they're quite simple to draw out. Just make sure you give it an attempt at labeling the axes, both of them, and giving a title. Okay, so this looks a little bit more scary, but it's really not. A line graph is for continuous data, and what we can see here is we've got two sets of data on here that we can compare against. So we can see G1 and G2. Both axes labels are on there. It's unlikely you'd have to do a graph this complex, but I've just tried to show you what it would look like. I mean, you might be asked to read a graph like this, but you wouldn't be asked to plot one. It would take far too long. But what we can see here is the green line, G1. They have quite a lot of low scores, and then they drop off really, really quickly. Whereas G2, they don't have many low scores. They've got more of a normal distribution to their scores. They don't have many high scores, and they don't have many low scores, but they've got quite a lot of kind of middle scores. So, if this had a title, we knew what the groups were, you could probably tell a story from this graph. Okay, a scatter graph. So this is used for correlations. We're trying to see if a relationship between two variables. Please, if you're a little unsure about this, have a little look at the correlation video where we talk about correlation coefficients. So this just shows the strength of a relationship between variables. So I think this would be like a 0.5 perhaps, maybe a weak positive or a medium positive. Don't join the dots up on this. Each of these are individual positive score. You could draw a line of best fit, but it's not necessary. And then you can see here I've put a little brackets around one in the corner, and that's because I've identified an outlier. So I'm saying, well, maybe this score doesn't fit with the rest. So yeah, that's what a scatter graph looks like. Again, we've got a title, we've got axis labels, and we can say from this that as one variable goes up, the other seems to be going up as well. Okay, now this is a histogram, so this is continuous data. So I mean, let's say, if for example, it's for a race, and we want to see the number of people that finish in the first 5 seconds, the number of finish in the next 5 seconds, then the next 5 seconds, and the next 5 seconds, and the next 5 seconds. So, you can see that's continuous. And we can see most people have finished between 10 seconds and 15. You don't know where they finished. I mean, one could have finished at 10 seconds, 0.0001, and one could have finished just before 15 seconds, or they all could have finished at 13 seconds exactly. That isn't, that's kind of included within the histogram. That's why the bars touch, because there's a range of data that each bar contains. Now, because each column shows a class interval, so from this to this, the bars must touch. So we've got an axis label at the bottom, we've got an axis label at the side, we've got a title. Please include all 4. Okay, so that was a quick look at graphs, charts, and tables. So make sure that you draw this as carefully as you can into your mind map. We will be drawing some of these up in class from data. So good luck looking over this, and I'll see you in class.